All right, so today we're going to finish up our material for the week, okay, looking at conic sections. So first of all, I'm going to just try to explain what conic sections are. There's 4 of them. We're going to study 3 of them, one today, one the next class, and one class after that. So conic sections are basically the different ways that you can take a cone, kind of slice it open, and then look at it. So a circle, okay, the way you could do that, you can have a picture of it over here, is if you took a cone and held it upright, sliced it straight across, and then looked at what you did, you would have a circle. Okay? Some people call it a cross-section. That's what it is. An ellipse kind of looks like an oval. Okay? The way you could get an ellipse is if you took a cone and instead of slicing it straight across, you sliced it at an angle. But it's important when you slice it, you're still going through the sides of the cone, not through the bottom. That's different. So an ellipse is kind of like slicing a cone on an angle and then looking at the cross-section. Parabola, that's also slicing a cone at an angle, but the difference is when you slice it, you go right through the bottom. So if you just chopped off kind of the side of the cone and looked at the shape, it would be a parabola. And the hyperbola is a little different. That's when you put 2 cones together, okay, at the points, and you slice it straight down. So if you put 2 cones together, slice it straight down, and then look at it, you would have these 2 curved shapes, and those are called hyperbolas. Right, so we're going to study parabola, ellipse, and then hyperbola in that order. We don't do circles because we kind of talk about circles throughout the year. And there's not really a ton of stuff to talk about with circles that you probably haven't already seen in other classes. So what I'm going to try to do for each shape is give you the definition, and then I have kind of an interactive thing on the board. I can show you like the shape and kind of explain the definition better with a picture. And then we'll get into doing some calculations. Just going to start with a circle. I'm not going to write anything down, but it's the easiest one to explain so you can kind of see the pattern of what I'm going to do today. So if I wanted to define a circle, okay, a circle has a center point. Okay? And then every other point, if you measure, well, pretend that's my center. If you measure the distance from every point to the center, how do all those distances compare? They're what? They're equal. Okay? So that's the definition of a circle. Every point is the same distance from a fixed center point. That's how you define a circle. It's a bunch of points that are all the same distance from a fixed point we call the center. Right? Right. Now I'm going to do the same thing with a parabola. Right? And that's what we're going to focus on for the rest of today. So a parabola is still a bunch of points. Okay? But here's where the definition is going to change from being the same distance from a center point. So it's a collection of points, and I'll call the collection P. P is all the points that make up a parabola, and it's in the plane. Plane means it's flat. Okay? Parabola is not a 3-dimensional shape. It's in the flat plane. If it was in space, that would mean 3D. Okay, but this is 2D. So it's a collection of points on a flat surface in the plane that are the same distance from 2 things. Okay? With a circle, everything was the same distance from 1 thing. That 1 thing was called the center. Okay. What are they the same distance from? Okay. They are the same distance from a special point we're going to call F and a special line we're going to call D. Okay, and when I show you that as a picture, I think it'll be very clear, the definition. Okay, so I'm going to bring up a picture of a parabola that I have sketched, and I can kind of drag some things around so I can demonstrate this. If you still need it, I'll put it right back up in a second. Okay, so what I have in kind of that purple color, that's a parabola. This point that I have the arrow pointing to, and this line that now I have the arrow pointing to, are the two things that I'm talking about here and here. You can call them F and D, you can name them whatever you want. Okay, in this program I had to name them a little different. But we're looking at a point and a line. There's the point I'm talking about. There's the line I'm talking about. Now, B is a point on the parabola. I can take B, maybe, and I can drag B wherever I want. It has to stay on the curve of the parabola. But notice what happens if you measure the distance from B to that special point, and then you measure the distance from B to that special line. That's the two distances I'm measuring up above. They're always the same. Okay, no matter how you move it, those two distances will always stay exactly the same. Okay? That's the definition of a parabola. The distance from the point to that point and the point to that line is always the same. Any questions on that? Okay, the two distances themselves, let me just try to get B again. The distances change, like 13, 8, 4, but when you compare the two, they're always the same. Okay, and the shortest distance would probably be about right there. Okay. And there's a reason why this is 3, and there's a 12 here. There's a way to get that 3 from 12. It has to do with dividing by 4, and it tells you the shortest distance. But don't worry about that yet. Okay. Any questions on the definition of a parabola? All right. With each conic section, there's some kind of vocab that goes with it. The reason I called it point F is because it makes it a little easier to remember the name of that point. It's called the focus. Point D, or line D, is called your directrix. Okay. Is anybody familiar with what a parabolic reflector is? So some headlights, if you look at the headlight on the car, the light that you see coming out of a headlight isn't directly from the bulb. It's all reflected off the back of the headlight and out. So let's say you had a headlight and it's shaped like that. Okay, your bulb would sit like that, and sometimes there's a covering over the front of the bulb. So you might be like, well, how do you even get any light if there's like this covering over the bulb? Well, what happens is when the light shines, it hits the back of the reflector and then bounces straight out. That's how a parabolic reflector works. No matter what angle the light hits the back of the light at, the back of the reflector, it then bounces straight out. Okay? And that's how some headlights work. It's a parabolic reflector. Get kind of the same thing in reverse on a satellite dish. Signals don't come out from the satellite dish, they come into it, like from outer space. So the signals come in to the satellite dish, they all bounce to that little point, and then there's usually a wire that goes into your house from there. But satellite dishes are usually in the shape of a parabola, because they can capture all the capture all the waves from outer space pretty well. If they were flat, that wouldn't really work. Okay, they have to have a curve to them. Okay, we don't really get into too many applications, but I'm just trying to show you one example that you maybe seen satellite dishes. That's a parabola shape. All right, so if you look at your packet, Figure 3 is summing up the definition of a parabola, writing it as an equation. This is saying the distance from the focus to any point is the same as the distance from that point to the directrix. That's exactly what I just wrote right here. Distance from the point, and then distance to the line. Okay? Just saying the same thing as an equation. Okay, the line through the focus and perpendicular to the directrix is called your axis of symmetry. Let's see. If that was a parabola, and that was your focus, okay, the parabola always wraps around the focus. That's what you want to remember. Parabola wraps around the focus. So if that's my parabola, and that's my focus, and I draw a line right through it, perpendicular to my parabola, that black line is a line of symmetry. Okay, parabolas are symmetric. Okay, on the other picture, I can't really draw on it, that's why I did it here. But my line of symmetry would come down right there. It would go right through point A, and it would be perpendicular to the directrix. So depending on which way the parabola faces, in this case, my line of symmetry would go up and it's a little off, but it would be up and down. In this problem, it goes left and right. Well, it depends which way the parabola opens. Okay, the point where your axis of symmetry and parabola cross is called the vertex. That dot that I just did in green, that is the vertex. The way I remember it, when you draw a parabola, it's either the highest point, the lowest point, the furthest left, or furthest right. It just depends on which way you sketch it. In those examples, there's your vertex, vertex, vertex. But if you want to think of it fancy, it's where the line of symmetry hits the parabola. Okay, there's another distance that they measure, and it's the width of the parabola. But you might be saying, well, doesn't the width of the parabola change? Because the parabola is always getting wider and wider. It does. But one particular spot they measure the width in is the width right there, going right through the focus. And if you measure that distance, they call it, our book calls it the lattice rectum. I don't come up with it, that's just what it is. It's also just called the lattice distance. Okay, we don't really do a lot with that, but if you see it, the lattice distance is the width of the parabola measured through the focus. Yeah, this is probably the last time we'll mention anything about it. Okay, so any questions on those terms? Vertex, focus, directrix, line of symmetry, lattice distance, a lot of different terms there. Okay. So, there's 4 different equations for parabolas. Why 4? Well, there's one opening up, opening down, opening left, opening right. We're going to start with this one. All of them kind of look the same. Sometimes it's y squared equals positive 4ax. Sometimes it's y squared equals negative 4ax. Sometimes it's x squared equals positive 4. Sometimes it's x squared equals negative 4. I basically just told you all 4 variations you could have. So whether or not this is positive or negative, and whether or not that's an x or a y, controls if it opens up, down, left, or right.
Wait, that's a comma 0?
That's a comma 0. Yep. So the standard form for a parabola, the way we're going to write it, is y squared equals 4ax. And if you're wondering what a is where the focus is. All right? So if I'll just try to make a sketch. Let's say, okay, my vertex is at the origin. Tells you that right there. And the focus is A0, but A has to be positive. So let's just say 2, 0. Well, the parabola has to wrap around the focus. So it would look something like this. So this is the equation of a parabola that opens to the right. Again, you really don't have to memorize that, because if you put your focus and you wrap the parabola around it, you can't really start at the origin and wrap around it any other way. You have to go right. If you go left, it doesn't wrap around it. If you go up, it doesn't wrap around it.
Wait, so if that went negative, would it be going to the left? Or is it a different number if it goes to the left?
It's the same number, but there'd be a negative in front of the 4. Yep. We'll do one of those.
Wait, so what's the focus? Which part of that?
The focus is right here.
And then what's that number?
And that's the vertex. The focus in this case, I just made it 0, 2, 0. Can be anything, yep. In this particular problem, it's 2. So now if I wanted the equation of that, the focus is at 2, 0. The number I just circled is A. So in my problem, A is 2. All I'd have to do is fill in 2. And the equation is y squared equals 8x. That would be the equation of that. Right? So you have to figure out where the focus is first, and then you're good. Okay. Let's look at this. Okay. My vertex is at B. How many units is B from A? In that, oh, I messed it up because I dragged it. There we go. How many units is B from A in that picture? 3. How many units is B from that line up at the top? 3. Notice B, the vertex, is exactly halfway between the two. Always. Okay? The vertex is always halfway between your focus and your directrix. So if I was going to put the directrix in here, the focus is 2 units right. The directrix would be right there. 2 units left. The directrix is just that imaginary line that the parabola bends away from. Your parabola never crosses the directrix. Ever. Okay? It bends away from it. Okay? Technically, the directrix is not part of the sketch. It's just an invisible line that, as I just said, the parabola bends away from. Okay, so when we're graphing a parabola, some things that are going to help you. Okay, you want to find the focus, because that's what it's going to wrap around. You want to find the vertex. And you want to find that invisible line that it bends away from. And then after you get that, we usually want to get points either above and below the focus, or left and right. Why could it be either or? It depends which way it opens. If the parabola opens to the right, then you would want to find a point above and below to make your sketch. Same thing if it opened left. You would need something above and below. But if it opens up, there's your focus. You want to find a point to the left and to the right of the focus. And that would give you your sketch. Okay, so whether you find points above and below or left and right to help you make a sketch just depends on which way it opens. And you'll know which way it opens by looking at the equation. You're going to look at the number there, you're going to look at the letter there, and eventually you'll know how to figure out which way it opens. generally when I sketch a parabola, that's all I'm going to do. 3 points. Okay. Vertex, point over here, point over here. There's my sketch. Okay. I could find more if I needed to. Like if I was going to draw this further and further out, I'd probably want to find a couple more, but we're not. Okay, so let's look at this one. So they want us to do 2 things. Find an equation of a parabola with the vertex at the origin and the focus at 3, 0. And then once we find it, graph it. Okay, so the equation we need to use is y squared equals 4ax. But let's say I didn't tell you that. You're going to have 4 choices. You use the equation where it opens right, left, up, or down. What I would do is graph the vertex, graph the focus, and what did I say about the parabola? It always does what to the focus? It goes around it, right? It has to wrap around it. Well, can't go that way. That's not going to wrap around it. Up doesn't wrap around it. Neither does down. It has to look something like that. So it has to open to the right. Now that we know it opens right, what we would do is look at our reference sheet and say, okay, what's the equation of a parabola opening to the right? And you would find that on your reference sheet. If you're looking in the packet, this is all in table 1. Okay, that's on page 381. So in that table, they have a column that says description. And in the description, they tell you the very last thing. Opens right, opens left, opens up, opens down. Okay. So I said, all right, it opens right. I look in the column right next to it. It said the equation is y equals 4y squared equals 4ax. Okay. So now we've got the right equation. What's the only letter I need to find in this equation? Mike? A. You don't ever change y and x, but you have to plug in a number for a. Well, the focus tells us what a is. Go back to what I just said. The focus is a, comma 0. So look at our problem. 3, comma 0. So what's a in this case? Yep. A is 3. Now that we know that, fill it in for a, and then that's the answer. So y squared equals 4ax. We usually simplify that. 4 times 3 gives me 12x. And that's the answer. Y squared equals 12x. Okay, now let's graph it. Well, I already have the vertex and the focus. Remember, the focus is not a point the parabola goes through, it's a point it bends around. So I need 2 other points. In this case, something above and something below. So I know, should it be narrow or should it be wider? How should I make my parabola? Okay, so let's pick a number for x. And you can plug in anything you want. But to get y, we're going to have to take a square root. Why? Because y is squared. So it'd be nice if you give me a number for x that when I multiply by 12, I can take the square root of it. And then I don't need a calculator. 3. So let's let x equal 3. So you're going to get y squared. Okay, and again, you could have picked anything you want for x. Okay? 3 is a good one. So if x is 3, let's write it over here. What would y come out to? 6. Take the square root. And now, when you take the square root of 36, you get positive 6. And what else do you get? Negative 6. So if x is 3 3, 6 is a point. And if x is 3, negative 6 is a point. You should always get 2 because of the symmetry of a parabola. So now graph 3, 6. 3, 6, 3, negative 6. And there's my parabola. Opening like that. Okay. So the focus is 1, 2, 3 units away from the vertex. If the focus is 3 units from the vertex, how far is the directrix? It's also 3. 1, 2, 3. There's your directrix right there. It's that invisible line that it bends away from. And the vertex is always centered between the focus and directrix. They didn't ask us to find that, but if you wanted to know it, remember vertical lines always have the equation x equals. Horizontal lines are always y equals. Negative 1, 2, negative 3. That's the equation of the directrix in this problem. Okay. And the chart tells you that. If you look at the table, it says the equation for the directrix is x equals negative a. Well, I have x equals negative a. So even if you couldn't get it from the picture, the chart explains how to get it. Any questions on that one? Let's see. Okay, let's try this one. You don't have to graph this. I just want you to tell me some stuff about this equation. So I'm giving you the equation. You're going to tell me which way it opens, the directrix, the focus, and the vertex. First thing is, this is not written the way we normally would write it. This is a final answer. Y squared equals 8x. We have to think of it like this. Y squared equals 4ax. So how could I write it like that? 2. The reason I wanted to do that is because now you can see clearly what a is. Y squared equals 4ax. So they must have multiplied 4 times 2 to get 8. Just like in this one, we multiplied 4 times 3 to get 12. Okay, so a is 2. All right, now I'm going to look at my chart. My letter is y. The 4 is positive. So I'm going to look in the equation column for the y with the positive 4. Okay, it's the first one. If you're looking at it, the second one is a y with a negative 4. And then the third one is an x with a 4. Okay, that's different. So, when y is positive and the 4 is positive, which way does it say the parabola opens? It opens right. Okay, next thing, it says, let's do the vertex. Where does it say the vertex is in that table? 0, 0. It's 0, 0 for all of these until we shift it. We are going to shift it, but not yet. Okay, the formula for the focus is a, comma, 0. So my focus is 2, 0. And the formula for the directrix, x equals negative a. X equals negative 2. So that's why I said conic sections can be kind of a pain. But really, if you've got a table and you put that on your reference sheet, all you have to do is look it all up, and it's not that bad. Okay. Any questions on what we just did right there? Okay. All right, let's look at this one. X squared equals negative 12y. All right, so that's not written the way we want to write it. We always write it with a 4 and then a number and then a letter. So in this case, we're going to put the negative with the 4. And if you're like, well, how do I know if the negative should go with the 4 or should the negative go with the number in parentheses? And it does matter. Look at what I wrote right here. A is never negative. Okay, A is always a positive number. So the negative does not go with A. It goes with the 4. A is going to be right there. Okay. So what's A in this case? 3. All right. So now we're looking for x and a negative 4. X is the first letter, and the 4 is negative. Which way does a parabola open if that happens?
Down.
Down. Right? Everyone looking at the table? So when x is by itself and the 4 is negative, it says it's in the last row. It opens down. This is on page 381, right here. Look at that table. Now, people that said left, what would have to happen for it to open left is it would have to be y by itself with a negative 4. We did y by itself with a positive 4, so that opened right. Okay. This is x by itself with a negative 4. What's the formula for the focus if it opens down?
0, negative A.
The formula, I'm just reading it off the table. 0, negative A. So for us, that would mean 0, negative 3. Okay, so we get 0, negative 3. What's the formula for the directrix?
A.
What equals A?
1.
Y equals A. I'm just reading it right off the table. So for us, y equals what's A? 3. There's my directrix. And the last thing they want to know is the vertex. Well, for all of them so far, what's the vertex always been? And it says it's 0, 0 in the table. Great. Any questions on that one? Now this one, they didn't say to graph it. They said discuss. Discuss means to write these 4 things. Does anybody want me to do a graph? You will on the test, but we did one earlier. This is a chance to do a second one.
Yeah.
Okay. So the focus is 0, negative 3. The vertex, remember it's going to wrap around the focus. That's why it opens down. And this time we're going to pick a number for y and solve for x. But it's the same situation. You're going to have to take a square root. So technically you pick anything for y, but if we pick the right number, we can do it in our head. What could I pick for y?
3.
Yeah, we could let it be 3. It's not always 3. So if y equals 3, we get x squared equals negative 12 times 3. All right, what's negative 12 times 3? Now, what would happen if you try to take the square root of a negative number? Imaginary. So what that means is you picked a point that is off the parabola. Okay?
Just do negative.
It's going to open down. Is that parabola ever going to hit 3? No, 3's above it. You picked a point that's above the parabola. So we can't pick 3, because that's up here. We have to go down here. So instead of 3, what could I pick? Negative 3. So just make small change. So now we have 12 times negative 3, gives me 36. And what's the square root of 36? 6 and negative 6. So we get 2 coordinates out of that. When y is 3, you get 2 answers for x. Positive 6, negative 6. Now graph those 2 points. Right 6, yes, negative 3, thank you. Right 6, down 3. My picture is probably going to be off a little bit. So 6, down 3, and then mirror image it on the other side. Left 6, down 3. And that's your parabola. Okay, so one thing you have to be careful of is you have to pick a point that goes in the direction of your parabola. If it opens down, don't pick a point above it. You're going to get imaginaries because the parabola doesn't go up. If the parabola opened left, don't pick x's that are positive because there's no graph over there. Okay? Any questions on the sketch there? Okay. All right, so this is one where you have to find the equation again. I'm not going to sketch it. Okay, let's look at our information and see if we can figure out which way the parabola opens. They're saying the directrix is y equals a negative number. And I think that's enough information to figure out which way it opens. In table 1, look at the row that has y equals a negative number. Yeah? It's going to open up. Even if you didn't have the table. Okay? Just draw what you have and try to use what I've shown you. The focus is 0, 4. The directrix is y equals negative 4. Does the parabola ever cross the directrix?
No.
No, it bends away from it. It bends around the focus. It has to look like that. It has to bend away from the directrix and wrap around the focus. If you say, well, couldn't it wrap around the focus this way? Yes, but then it would eventually cross the directrix. So that's no good. Okay, so it's going to open up. Now that we know that, we can look up the equation when it opens up. Okay, what's the equation for a parabola that opens up?
X squared equals 4ay.
Yep, just get it from the table. X squared equals 4ay. What letter do you have to fill in for there? A. But we've said that earlier. A, right, is the distance from the focus to the vertex. Well, where's the vertex? It's halfway between. I tried to explain that earlier. The vertex is always halfway between your focus and your directrix. So look at the distance from the focus to the vertex. Vertex, focus. What's the distance?
Is it 4?
4. What's the distance from the vertex to the directrix?
4.
4. Should always be the same. They're halfway between each other. So A is 4. Fill it in. And that's our answer. So x squared equals 16y. And that's it. That's the equation. Any questions on that one? Okay. Let's do... All right, let's do this one. Let's do this one quick. So directions here, find an equation. I'm going to graph what I have and try to figure out which way it opens. Vertex is 0, 0. And the point, negative 1/2, 2, is on the graph. So contains means it's on the parabola. Based off of going through this point, and that being my vertex, and the axis of symmetry is the x-axis. That's my axis of symmetry. Which way does this parabola have to open? It has to open left. If it opened right, it's never going through that point. That's not going to work. If you said, well, what about opening up? No. If the axis of symmetry is horizontal, your parabola has to go this way or that way. It's the only way the axis of symmetry can be horizontal. Okay. So it has to open left. Kind of like that. And the axis of symmetry goes right through it. What's the equation for a parabola opening left?
Y squared equals negative 4ax.
Yep. And what letter do I have to fill in for? I have to find A. Did they tell me the focus?
No.
Did they tell me the directrix?
No.
Then I have a problem. I'm stuck. Because those two things are what I could use to find A. But they did give me something else. They gave me a point. A point is made up of an X and a Y. Well, if you fill that in, and you fill that in, you can find what A is. Okay, so you have to plug the point into the equation and get A. So we have negative 1/2 squared equals negative 4A and, y is 2, sorry. So plug in 2 for y, plug in negative 1/2 for x. Okay, what's negative 2 squared? Actually, it's positive 2. 4. On the other side, what's a negative times a negative?
Positive.
It's a positive.
2.
And then half of 4 is 2. And then what would I do to get A by itself? Divide by 2. So there's A. So now you use the coordinate, plugged it in for x and y to get A. Now you can fill in for A, and what would you get for your final answer? Negative what? Negative 8x. Okay, so that's pretty much all the different ways I can give you a parabola at the origin and have you find the equation or graph it. Okay, sometimes I might give you the focus, sometimes I might give you a point, but I've tried to give you one of everything you could see.
Wait, can you go up again? So the 4 is just assumed?
The 4? Yeah, that's part of every formula. We looked that up in table 1 in the
Well,
chart.
I just didn't understand why it's negative, but I get it.
Yep, that's in the table. All right, so this is the table that's very similar to table 1, but notice there's one thing that's different about it. Those aren't all 0, 0. Okay? They're h comma k. So your vertex doesn't always have to be a 0, comma 0. You okay?
Yeah, I'm fine.
But you use this table exactly the same way. Okay? H and K are going to be the coordinates of your vertex. There's the formula for the directrix. You don't even have to think about it. It's all right there. This is the formula for the focus. And here's your equation. Basically like you had before. You've got y squared. You've got a positive 4. Y squared, negative 4. X squared, positive 4. X squared, negative 4. So you still have the opening up, down, left, and right. The only difference is this and that. So whatever the coordinates are of the vertex, you put those two numbers in those two spots. We'll go through an example or two. Okay, this is table, if you want to write it down, it's on page 383. So you don't have to copy it, it's all in your packet.
So for these ones, it'll be the vertex, is that what you're trying to say?
Yep, for these problems, they're going to tell you the vertex. Okay. So again, I'm just to say the same thing again. H comma K is the coordinate of the vertex. And A is always the distance from the focus to the vertex. Okay, that's very important that you remember that. Okay, I think I wrote it earlier. A is the distance from the focus to the vertex. I'm writing it again. That's how you find A. And remember, the vertex should be centered between the focus and the directrix. So technically, the distance from the directrix to the vertex and the focus to the vertex, those should be equal. Because the vertex is always right in the middle of the two. It just takes a little practice to get used to remembering that. All right, so you don't need to copy that. So let's look at an example. All right, so this time the vertex is -2, 3, and the focus is 0, 3. There's 3 letters I need to find. We always have to find A, but what are the 2 new letters I have to find?
H and K.
H and K. Okay, let's start with A. Go back to what I said. A is the distance from the focus to the vertex. Well, here's your vertex, here's your focus. If you were to draw those, what's the distance between those 2 points? Not 3. Think about if you graph them. One of them is left 2, up 3. The other one is just up 3. 2. Right? They're at the same height. They're both at a height of 3. One of them is 2 units to the left. One of them is right on the axis. So A is 2. Any question on how I got the distance between the vertex and the focus? What is H? -2. Right? The vertex is at H, K. Your vertex is at H, K. So H is -2, K is +3. Now you have everything you need. Fill it in. How do you know which one of these formulas you should fill into? You have 4 choices. They all have H's, K's, and X's and Y's. What do I have to determine to figure out which one of those to use?
Graph it and see what it opens.
See which way it opens. Well, I already graphed my focus. Here's my vertex. Based on that, which way does the parabola have to open? It has to open to the right. It has to wrap around the focus. Again, we're not sketching it to sketch it as part of the directions. We just want to figure out which way it opens. It opens right. Look at your chart. Fill all your numbers into that equation. That's how you do it. Okay, so we've got y minus k squared. And be careful with a double negative. So we've got y minus k squared equals 4a x minus h. 4a is 2. We should do that out in a second. X minus, what's h?
-2.
H is -2, so it's x minus minus 2. So it turns into a plus. Okay, so final answer. You don't do that out, you just leave it. 8x plus 2. That's the equation of the parabola that has the focus there and the vertex there. Any question on that? So this chart is key. You can write that down or print it out, photocopy it, glue it on your reference sheet, whatever you want to do. But I would put that chart on there. Just copy something down we had earlier. squared equals negative 12y. That'll work fine. How would you get y by itself there? Divide by negative 12. So if you wanted to type that into your calculator, that's how you have to do it. You have to get y by itself. The other reason I'm showing you that is, let's say you get that when you solve it on the test, but that is the multiple choice answer you see. Well, they're the same thing. You just have to know all that I did was move that to the other side. Okay. What number is in front of x here, even though it's not written? 1. So you could also think of it this way. It's 1 over 12. 1 over 12. That's also the same thing. So when you look at the letters here, what do you notice about the x compared to the y? What's different about the x letter and the y letter? One of them is squared, one of them isn't. That's the whole key to knowing you have a parabola. Parabolas always involve two variables, x's and y's. One of the variables is squared, the other is not. Now, when we talk about ellipses and everything else, they also have two variables. The difference, they are both squared. So that's what can make conic sections kind of confusing. All the equations pretty much look the same. All of them. Except sometimes both of them are squared, sometimes it's only one of them squared. It can get confusing. Parabolas are a little different than everything else. So it's kind of good we get parabolas out of the way, we can kind of forget about them. And then the next two that we do are almost the same thing. So it's good to kind of group those together because they're similar. Okay, so that's parabolas. Any questions on that? Okay, so homework, remember that's in the packet. There's a lot of matching in the packet, so it's not all doing things out. It's 11 to 18 all. On 19 to 31, don't do what they're writing in the packet. Only find the equation and graph. They're going to ask you to do something with the lattice distance. I told you we're not going to do that, so don't worry about it. And then 37 to 41, just the odds. Okay, so we'll go over that before the test tomorrow. Remember that your term grades will be posted online later today because I have everything I need to do that.